life of the equipment. I hope that concept is clear. So, routine service and maintenance should be scheduled at regular predefined intervals so as to ensure uninterrupted workflow. This is assuming that you have a valid contract with your equipment manufacturer or a third party. The laboratory must have a documented process and maintain logs for preventive maintenance. Very important again, documentation. The schedule for equipment maintenance and calibration need to be prepared in advance as per the manufacturer's instructions and circulated among all laboratory staff so that the same can be rigorously adhered to. Preventive maintenance provides the following advantages over breakdown maintenance. We already saw the diagram, just to reiterate, because it helps in giving you quality assured results, reduced breakdown and hence higher productivity, timely identification and replacement of components showing excessive wear and tear. So while they examine, they see something is not correct and something is getting worn out, the technical support team will change those parts. It's not a predictive maintenance, it's actually a preventive maintenance. So this certains greater safety, lowers repair costs, and it prolongs the instrument lifetime, and it also reduces your downtime. So now we have to move on to your next concept, and before that we would like to just recap about the maintenance part. We have talked about maintenance. We have talked about two kinds of maintenance here. One is a maintenance by authorized, you doing the authorized maintenance steps by the laboratory staff in a scheduled way, daily, weekly, monthly, or as required. And there are other maintenance steps which are not authorized to the laboratory, so let's call them unauthorized maintenance steps. This can be done only by the technical support team, so that those have to be scheduled in a certain way as per the recommendation of the manufacturer itself. Okay, I hope that is clear. Authorized steps done by the laboratory as per the schedule of the manufacturer, again as per the requirement of that machine and how much it is used, and depending on that, and other preventive scheduled maintenance which is done by the technical support team. For those steps which require certain inputs from the technical support team, because there are certain parts which will not be accessible, for those you will have to call the technical support team to come in, and so that they can do the preventive maintenance on this scheduled basis. This is like generally maybe a 3 monthly, some equipment may have 6 monthly. So you have to look at the manufacturer's instructions, and while you are making your MQ, both these are important. Authorized maintenance step by your frontline staff and unauthorized maintenance steps by your technical support team in a scheduled manner. So that is your MQ. And after MQ, we come to another vital concept which is also part of your routine maintenance, which is equipment safety. This is an ongoing process to ensure that the safety of the equipment and the personnel is maintained, and all electrical and mechanical safety features are regularly checked and maintained. There are multiple concepts apart from electrical and mechanical safety, but they are primary issues here, and other concepts also will briefly give an overview. First, we'll go to the electrical safety. All equipment, wiring and cords must be maintained and used in a manner that keeps electrical insulations intact. Electrical appliances and equipment are protected from overloading by means of fuses or circuit breakers should be ensured. Grounding of electrical equipment should be checked regularly, as it provides some protection to equipment operators. If there is a fault in the equipment or insulation that energizes the equipment housing, the electricity would flow into the ground rather than to the worker. This is the importance of grounding of an equipment. Electrical shocks can be avoided by ensuring that the equipment and electrical cords and plugs are in good repair. Grounded outlets are used and ground fault circuit interrupters or circuit breakers are used. Check that there is no overload of electrical circuit. Minimize and eliminate the use of multi-outlet power strips. This is an important concept. The extension cord can actually result in some kind of overloading, so this has to be used with caution. Since electrical devices can generate sparks, ensure that they are not used near flammable or volatile gases or liquids. That many points to consider regarding equipment and electricity. There are so many other points. This is some in brief something that you need to be aware of at the very outset. Now regarding equipment and mechanical safety. After electrical safety, we need to think about mechanical safety also. This is also a very important concept, especially in certain equipment. So let's discuss a few examples of mechanical safety. It's not possible to discuss all examples, so we will just limit ourselves to a few key equipment. Equipment design that include advanced safety features such as audible or visible signals. We already talked about this when we were talking about purchasing considerations. And availability of interlock or key lock systems and permanent shieldings, etc., should be considered whenever possible. An interlock system is a feature that makes the state of two mechanisms or functions mutually dependent. It's used to ensure occupational safety in mechanical devices and systems. This is a very important concept because if a certain part is moving, that part will not move if that equipment is open. There will be a door which will be connected to that moving part. So if the door is open, it will not actually move. But then people do some self-defeating steps like jamming the door or keeping it semi-open, and that is a very self-defeating thing to do, and such things should not be done because these are all made for the protection of the worker. So please check that during this kind of option during the purchase part itself. And as I said earlier, never resort to self-defeating steps like opening equipment while it is working. In some old model centrifuges where interlocks are not available, it should always be borne in mind that careless handling of equipment can cause great hazards. Sometimes it's seen as a practice also that even before the centrifuge stops, the lid is opened. It's a very risky practice because of two things. One is aerosolization, because it's a biohazard. Most of your samples will have some pathogens that can be airborne. That's your very hazardous thing to do. And also sometimes the chest tubes break and fragments of glass can just fly out and can injure you. So there are so many hazards because of opening a centrifuge while it is working. And another very hazardous equipment as far as physical safety is concerned is microtomes. Some of you may be using microtomes, so just a few precautions. Do not handle the blade with unprotected hands. Microtome with non-disposable knife should have a safety shield. It's a very extremely important step. Make sure to use forceps and wear gloves. Do not leave the blade exposed during sample loading and unloading. Always remember to cover the blade. Cover the blade by using provided finger guards or protective foam guard over the blade during mounting and removal of the sample. Use forceps to remove the blade and wear 2 layers of nitrile gloves to help protect your fingers as far as possible. You do that. Final big warning is do not skip personal protective equipment while using microtomes. This will prevent lacerations and cuts. So now we talked about two kinds of safety where equipment is concerned, electrical and mechanical. Let's go to the third, which is a biohazard and biosafety. Every effort should be made to prevent equipment from becoming contaminated and to reduce the likelihood of equipment malfunction that could result in leakage, spill, or unnecessary generation of aerosolized pathogens. Ensure that the service of equipment gets done according to the manufacturer's instructions. Ensure that anyone who uses a specific equipment or a piece of equipment is properly trained in setting it up, using it, and cleaning. Decontamination is a big word. This is a process, a very, very important process for removing or killing microorganisms. It is also used for removing or neutralizing hazardous chemicals and radioactive materials. All equipment should have a laid down protocol for decontamination. It is carried out on a daily basis after the work of the day is over. It's also done on as required basis, especially after spills. So, which equipment need decontamination? Every equipment requires decontamination. Your fridges, your centrifuges, pipettes, biosafety cabinets, all laboratory equipment requires decontamination processes. And apart from equipment, you also need to clean other areas. We are talking about equipment here, but we also need to be aware that decontamination processes involves lab benchtops, sample collection areas, effluents, contaminated solid waste, etc. So decontamination practices should be part of your laboratory safety protocol, not just in equipment but also in other areas. From decontamination, we move on to biomedical waste disposal. Most equipment will generate liquid, both reagent waste, byproducts, waste from laboratory, from the samples. All these will become part of your equipment effluent. Effluent is a major concern for laboratories. When placing an equipment in the laboratory, it should be made sure how to consider liquid waste will be handled. To be aware of this and comply with local and national requirements for liquid waste disposal in order to prevent contamination of the community sewage systems with pathogens and toxic chemicals. So that's the next effluent management of liquid effluents is also a very important thing that we have to think through while we are operating our equipment in the lab. Now that we have talked about few aspects of equipment safety, there are other aspects that we have not included in this discussion, but you can read more about it in the equipment management module and in the facility safety and management modules, which are also on this website. All these will include ultraviolet safety, laser safety, glassware safety. These are all considerations of equipment safety, and this also should be thoroughly understood. Please read those modules which are available on this website. So we are done with now maintenance. So we have come to the next concept, which is indirectly part of your maintenance, but also a totally different aspect of it, which is backup equipment or backup referral labs in the case of breakdown. In certain circumstances, example, an analyzer repair or breakdown, lack of available consumables, lack of required reagents, control materials, continued failure in EQUAS, etc., a laboratory may need to use backup equipment or backup laboratory for testing and reporting. The lab must develop a policy for use of backup instruments or laboratories in case of failure of testing equipment for all analytes being tested in the laboratory. So you should have a backup plan. There can be breakdowns, so what is your backup plan? To ensure that the quality of the result or data produced using the backup equipment, the primary laboratory must be able to demonstrate acceptable